Okay, Rich Alverson here, ITS148. It's 145, and today we're going to finish up Chapter 5. Let's see, let me share my screen here. I'll finish up Chapter 5, and then we will I'll go over an assignment that I made for you for this chapter. So let me share my screen. This one. And so this is where we ended up last time. We had just finished talking about the break statement and the continue statement inside loops. The idea is that you can, that if for some reason you want to exit a loop in the middle, let's say it's a while loop, and normally the way you exit a while loop is that you have to finish the pass and then come up to the top here and check to see the while condition to see if it's true or false. And if the while condition is false, then the looping, the iteration ends, and you proceed you know, with the code that's just past the while loop. But for some reason, if you want to write your code so you also have a check in the middle, and in this case, we're talking about this future value application where you're calculating the accumulated interest, and accumulated monthly interest on some money you put in the bank or something, monthly payment, future value of a monthly payment. So it's so you're the monthly payment times the interest rate. Yeah, okay. So it's the future value of an investment where you're putting in monthly, and computing how much interest you make each month and adding it to the future value. There are equations to do this all in one step, but those equations tend to be quite complicated and use you know, E and exponents and all that. And what's nice about computers is you can write a program that does it very basically, you know, very basic, you know, very simple rudimentary code, and you just you know keep on executing it until you know you've reached the point that you're done. So in a case like this, you're computing the future value. You start out with a number, with a monthly payment amount, and then you just you know, go month by month, adding the monthly payment plus the interest that you gain on what's in there already. And if you're going to do it for 10 months, you just make your loop 10 times, and at the end you'll just be able to you know, display out or write out what the final answer is. In this example, you want to, for example, if the future value ever becomes greater than 100,000 for whatever reason, then you can then there's a check in the middle that would exit the loop, and that's where the break is used. Continue statement here is where when you reach a continue statement, it actually goes back up to the top and starts the pass over again. So it skips the code that's below the continue statement. All right. So for the remainder of this chapter, we cover again breakpoints and execution points, and it's actually in 128. I'm teaching 128 this semester also. You had 128 last semester, and we didn't cover breakpoints last semester in 128. It's because it was not in the textbook that we're using, but in this semester we're using a newer textbook, and so we actually are covering it. So I should spend a little bit more time covering it this semester. Since presumably if you had my course last semester, you haven't really seen it yet. You may have fiddled around with it, but the way breakpoints work is in the code file here. You can go way over to the left and click, and a red dot appears, and this ends up being a breakpoint. And the way a breakpoint works is as it's executing, it actually stops at the breakpoint. It stops just before that statement is executed. And then you can step through it one statement at a time. And you also have these windows down here at the bottom where you can actually see the values of all the variables as you step through it one statement at a time. So if you're trying to figure out an error, you know, it's very handy because you can actually, you know, stop it at a statement and look and see what the variables are. And if there's some calculation that's wrong or some assignment that's wrong, you can, you know, identify it presumably right away. So to set and clear breakpoints, you set a breakpoint by clicking or tapping the margin indicator. If you remove it, you can. There are several techniques to do that. Let me pull up some sort of Visual Studio something or other here. Let's see, resources. What do we have in resources? Chapter exercises. What do we have here? Let me open up something in here. Invoice total. I'm going to do this one here because it's a finished one. I'm going to put this on the desktop. And let me open it up. Where is it? It's here someplace. I thought I put it on the desktop. It's not on the desktop. It's probably downloads. Let's do that again. What's this? Where is it? Show all. Show in folder. Oh, 3D objects. That's nice. I'm going to move it over to the desktop. And here it is. Right click, extract all. Extracts it and enters it. Let me just start this up here. Wonder how it decides which window it opens up. All right, so let's just start this up, see what this program does. All right, so we have a program here, and we enter in some subtotal like 50, and it actually calculates these things up. 50. So let's say we have a. Let's open up this code, and let's look at the code. Here's the code. Now, okay, so here we are, calculate button. Let's see, let's do something like, let's put a breakpoint right here. Okay, so I just clicked over there. And now let's run this again to see what happens. And here we go, so I'm gonna put in 50, calculate, and boom, stops right there. Okay, and look down here in this autos thing, it says, did I type in 50? I wonder why it says invoice total is equal to 37. Invoice total, where's invoice? Well, all right, number of invoices is 0. If you roll your mouse over a number of invoices, you can see there's a 0 there, and where's the decimal? Invoice total. Oh, okay. It's because it takes the subtotal, subtracts the discount amount. Okay, so that has already been calculated. That's what that is. So I typed in 50, and the discount percent is 0.25 of 50, which is 12.5. Let's see, discount amount. Discount amount. Yeah, 12.5. You see, I put my mouse over there. Let's go to locals. Discount percent is 0.25. Discount amount is 12.50. So the invoice total is 37.50. That makes sense. Invoice total is 37.50. We're at the breakpoint here. And so we see the number of invoices is, let's go back to auto. Number of invoices is 0. So now let me step one step. So I'm just going to execute that statement there. And I can do it by see, if you look up here, this thing, step into means just execute one step, or execute one statement. This will step over it. This steps out of it. Okay, so I'm gonna click this step into. So I'm gonna go click, and it goes down to the next one. And we see now number of invoices has been increased to 1. And now we're down here. And its total invoices is still 0, so it's going to add the invoice total to total differences. It's going to add the invoice total to total of invoices. So let me just click that one, click, and we see that statement was executed, and now total of invoices is 37.50. You see it's red. So and with watch, you can actually like type in the names of variables. If your program's got a lot of variables and you just want to watch certain ones, you can type in the name of the variables here. And I'm going to try to do this. I'm going to try this smallest invoice. So now I'm going to execute one more time. And smallest invoice right now is nothing. So that's a nothing, I guess. Let me do one more. Click. One more. Click. Now smallest invoice is equal to something. Before it was smallest invoice. It was whatever the maximum value, whatever the maximum decimal value is. So that's what it's initialized at. And the reason they do that is because if we're going to keep track of the smallest invoice, we want to initialize it really, really high, the highest number possible. And so that way, the first invoice it encounters will be recorded as the smallest invoice so far. If we set it to 0 or something, and all the invoices are greater than 0, then we will never find the smallest invoice because we initialize the smallest invoice as something smaller than any invoice. Yeah, if that wasn't clear to you, it'll be clear to you later. All right, so that's how you make breakpoints, and then we can just continue. I can remove the breakpoint by going, there's various ways. I'm going to click on it and it just goes away. and then we can continue. Let's see, how do we continue? F5, and it finishes up, waiting for another value. All right, so we will find ways to use breakpoints later on in life. The programs we're doing right now are actually quite simple, but later on, when our programs get a little bit more complex, we may find a need to use breakpoints if there's some nasty bug we just can't seem to figure out. All right, so that's how to set and clear breakpoints. You can step through your code, continue normal processing. So you can use these F keys also. You can step through your code using F11, so you just tap on F11. That's the same as tapping on that little button that was up there when the thing's running, and then you can hit F5 to continue through the breakpoint. The exercise in the back of chapter 5 is to actually implement this future value form. And so you enter in a monthly investment, and you enter in an interest rate, and you enter in a number of years, and then it goes through that looping thing and calculates what the future value is. So you would monthly investment each month, so you would iterate each month, and the yearly interest rate is 7.5, so each month you would get 1/12. The interest rate would be 1/12 of that, and you iterate over 12 times 10, which is 120 months. That would 10 years is 120 months. Then after you're done, you should get some larger value like that. So we're talking about this loop here. And this takes you through it. It sets some additional properties for tabbing. And this is the code. We compute the number of months because we're going to iterate over months. And so this is the monthly interest rate, is the yearly interest rate divided by 12 divided by 100, because we enter in the interest rate as a percent, or as a percent, I mean, times 100. So we have to actually figure out what the actual interest rate is, 0.0 whatever. And then this is the loop through the months. And each time you take the future value, you add the monthly investment, and then you multiply by the monthly interest rate plus 1, because that's how the equation works. And then when you're all done with the loop down here, you write that future value into the future value text box. And then you put the focus back on the text box to enter in a new monthly investment. There's some extra exercises. There's one on factorial, calculating the factorial of a number. That's also a loop. I didn't choose that exercise. I chose this exercise, calculate change. So this is our assignment. This is our assignment for this week, for chapter 5. And with this assignment, you enter in some number less than $1, and you're supposed to be a cashier, and you got to make you have to give, let's say it's change from somebody paying for something, and you have to give them back some change. And so this little program here will calculate the number of quarters, the dimes and nickels and the pennies that you give the person. Now, you could do this with loops. I thought about asking you to do it with loops, but it's easier to do it with just dividing and figuring out what the remainder is. And then so we take this number 68, we divide it by 25. See, quarters is 25, dimes is 10, right? Quarters is 25 cents, dimes is 10 cents, nickels is 5 cents, pennies is 1 cent. So we take the 68, we divide it by 25, and we get 2, and the remainder is 18, yeah? Remainder of 18. And then we take 18 and divide it by 10 to figure out how many dimes there are, and we get 1 with a remainder of 8. And then we take the 8, divide it by 5 to figure out the number of nickels, and we get 1 with a remainder of 3, and then that would be the number of pennies. So let's pull up that assignment. It would be write assignments right here. So this is the assignment. In this exercise, you'll develop a form that tells how many quarters, dimes, nickels, and pennies are needed to make change for any amount of change 0 through 99 cents. I also thought about, going higher, like some number below $50, and you figure out how many 20s and 10s and 5s and 1s and quarters, dimes, nickels. But I just thought I'd keep it the way the book has us do it. So, so one way to do it is to use the division and modulus operators to cast the result of the integer of each division to an integer. So, so I'd like you to start a new project named Change Calculator. Add the labels and text boxes and buttons to make it look like this. When the user presses the Enter key, presses the Calculate key. You can, from here you can hit the Enter key. So you want to be able to type in 68 and it hits the Enter key, and that's the same as clicking the Calculate. So you want to set that up. And when the user presses the Escape key, that it's like hitting the Exit button. So you want to set that up. Then create an event handler for the click event. And then write the code for calculating and displaying the number of quarters, dimes, nickels, and pennies that are needed for the change amount to enter for the user, the change amount that the user enters. This code should provide for integer entries, but do not assume that the user will enter valid integer values. Okay, so that means I want you to do try parse. User types in something else, you want to say, whoa, type in an integer between 0 and 99. And then you want to create an event handler for when they click the Exit button. You want to test it and then zip it up and submit it. You can, let me close this. Well, let's just start a new project. It would be Windows Form application. I'm going to put it on the desktop. And I'm going to call it Change Calculator. So here we are. And so we want to make something that looks like this. So let me pop out my toolbox. Let me pin my toolbox. Click on the form. I'm going to scoot this over. And let me put some labels. Put a label there. Put a label there. Another one, quarters, dimes, nickels, and pennies. And then I want to put a text box. Text box here. And are these labels? I think they're labels, yeah. Can you put a square around the label? Image? I've never done, actually, I've never, back color, border style. I don't know. That looks kind of like a label. Make it bigger. You make it bigger by going. I should have done this beforehand. Let me. Oh, I know. Let me open that other one back up again. Because this one's got these. So what is this? This is a waiting for something. Okay, there's the form. This is a text box. And this is a text box. So this is a text box which must be,
I think that's the read only.
yes, read only, yes. So where's read only? There we go, true, got it. All right, that's better. And okay, right, okay, so let's go back to this. Let's change, let's get rid of this. Let's do another text box. Thank you. And we will make it read only. Read on, true. All right, so let's start. Okay, so this is gonna say amount of change due, 0 to 99. And are we gonna, let's make it bigger. Can I make this bigger? Yeah, so let's do that. And can you do a, text align? I'm gonna align right. And let's make this 18 like the other ones. 18, just because it is. And I'm going to make 1, 2, 3, 4. 2, 3, 4. And I'll put one there, and I'll put one here. And I'll put one here. You can mess with that. And I'm going to get rid of these. And I'm going to double this one, and this is going to be quarters. Oops. I'll get rid of that in a second. Quarters. It's not top writing. Okay. Got to do it by hand then. Okay, this one goes here. And dimes, nickels, pennies. Dimes, nickels, pennies. So this would be dimes. Oh, still not going to work, is it? Nickels. And pennies. Okay. And this is going to be, I'm going to rename these things. TXT change do. How's that? And this is going to be TXT quarters. And this can be TXT dimes. And this can be TXT nickels. And this can be TXT pennies. And I'm going to need a calculate button. Make it BTN calculate. Calculate. I want to make it bigger. Oh, yeah, right. Bigger. I'm going to name it BTN. No, the text is going to say calculate. But I'm going to make it bigger because I want to. And there's my calculate button, and then I need an exit button right here. And so I'm going to name this one, say exit. And I'm going to name it BTN exit. All right. And then I got to make it so when you, the form, I got to make, oh, I'm going to name the form FRM calculate change, just because of that. And up here in the text, I'm going to put Richard's excellent change agent. Whatever. All right, and then I want to make it so when I hit the enter key here, it's the same as the calculate. So first of all, I got to create a event handler. Double click. There's an empty event handler. That's fine. Oh, this thing, I want to get rid of that. So how do I get rid of that? Well, first of all, I got to find what's referencing it. It's label 2. So I'm going to go over here. I got to find label 2. Is it this one? That's label 1. Label 2. I got to go into the event handlers over here. I'm going to put this up here. The event handlers, here it is, the click event handler. This is if somebody clicks on that label. If somebody clicks on the label, it goes here. I don't want that. So I'm just going to get rid of this event handler, delete, enter. So now there's no event handler. Is there still an event handler over here? No, it's gone. Good. All right. So now I've got that event handler. I'm going to make an event handler here, double click, and I'm just going to say this close. There, that's done. And so let's go back here, and I'm going to click on the form itself, and I'm going to make action. Oh, is it a form or a property? Let's see. Accept button. I want that to be button calculate. And is the cancel button, is that escape? I don't know, I think so. Button exit. Okay, so well, we're getting there. I'm gonna try that cancel thing. I'm gonna click start. And here it is. And what happens if I hit escape? Ah, good, that works. All right, so now we just got to enter some code. Oh, what did I just do? I don't need to do that. So let me go over here. And let's see, I'm gonna read in the change. All right, I'm gonna read in the change. It's gonna be a decimal change. I guess I'm gonna start up by setting it equal to 0, I guess. And then I want to, no, I don't need to do decimal. I'm going to do integers. I'll leave it that for a second. Yeah, I'm going to do integer. See if that works. I'm not sure. I haven't done this yet. So if int try parse parentheses, I'm going to read in text change do.text. If that parses into an integer, then dump it into change. If it's equal to an integer, it's going to return true, and the new value is going to be inside change. So let me just do this. Do I need to go out or something? Yeah. All right, there we go. And so I got the change. Oh, and I can do else message box show. Please enter an integer value for the change due between 0 and 99. Yeah, okay. Not technically that, but all right. So let's see, got some change. First thing I want to do is figure out quarters. Okay, so let's initialize some things here. We're gonna int quarters equals 0. Oh, if it's an integer, it's not an M. Int dimes equals 0. Int nickels equals 0. I have to figure out some place to stop here because I gotta leave something for you guys to do. Int pennies equals 0. And so let's start by figuring out the number of quarters. So I can say quarters equals int change this work? Change divided by 25. I think so. And then I go, so that's going to be an integer number. It's going to be the number of quarters, and then I need to get the remainder. So I'm going to say change is now equal to well, I'm going to say well, change equals quarters times 25 change equals change minus quarters times 25. Blah, 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 text quarters text equals quarters to string. Let's see what this looks like. 68. Enter. Looks right to me. 74. Enter. Oops. Oh, that's escape. If and double ampersand, because if that first one's got to work, and then the second one can be, and change is less than 100, and change is greater than or equal to 0. Okay. Start. 674. Please enter an integer value for the change due between 0 and 99. All right, that works. So 74 calculates to 2 quarters. 75 calculates to 3 quarters, as does 76, as does 99. All right. What an easy assignment, man. I think I'm going to stop right here. All right? You guys can fill in the rest. Oh, tell you what I'm going to do. Just to make sure that this number's right, I'm going to just put a little label here. I'm just going to put a little label here that just because I have stopped. I'm going to put it right down here. I have stopped after calculating the first one, and I want to put the change, whatever the change is, right here. Okay, just so because what? Well, you'll see what I'm doing. Let me name this LBL change. I'm just going to put that. All right, so that's that, and I'm going to make it. Where's the text? Here it is. I'll just put an asterisk there or some silly thing like that. And over here, I'm just gonna say LBL change dot text equals change to string. So let's see what this does. So when I say 74, enter, yeah, that's right. So it's 2 quarters, and then there's 24 cents still left to to split up between the dimes, nickels, and the pennies. So if I say 51, it's 2 quarters, and there's only 1 cent left. So what I have shown is that this calculation is correct. This is getting me the right change, and then I got to do the same thing. I've done change divided by 25 to figure out the number of quarters. Then I got to take what's left over in the change. That's what this is, leftover change. Take that, do the same thing for dimes, and then there's going to be some leftover change. And then do the same thing for nickels. And there'll be some leftover change. Do the same thing for pennies. So I can do like this. Compute number of quarters. Okay, and this is, I know, I'm going to do this. A lot of comments here. Compute number of quarters. Compute, oops, compute, not computer. Compute leftover change, display leftover change. And then I want you to do compute number of dimes from change. Compute number of dimes from leftover change. And then, I wonder why I keep putting an R there. I can't imagine why. Compute leftover, it's probably one word, change, compute display leftover change. So, you know, here I've actually put the statements, and then I have the comment. So I want you to put the statements here, put the statement here, put the statement here, do the same thing for, this is dimes, nickels, pennies. Compute nickels, compute dimes, nickels. I think we're done after this. And so we would want, at the end here, we want txt dimes dot text equals dimes to string, and txt nickels txt equals nickels to string, and oops, and txt pennies text equals something. I'll let you figure out the last one. All right, so so you can probably finish this up in the next 5 minutes and go home. All right, this is an easy one. I didn't realize this was so easy. I should have done it first. All right, so I will leave you to finish this assignment, hand it in, and next Thursday we'll start chapter 6. Huh? So next Thursday we will start chapter 6. Are there any questions? All right. Thanks for watching.